You think you understand gravity. You stand on the ground, feel your weight, and assume something is pulling you down. Simple, obvious. Almost everyone believes this without question. But what if that feeling is misleading? What if you have never actually felt gravity in your entire life? Right now, wherever you are, pay attention to your body. What do you feel? Pressure under your feet, maybe against your chair, something pushing up on you, not pulling you down. That upward push is the only physical sensation you experience. The so-called pull of gravity is strangely absent. You believe it is there, but you never directly feel it. This creates a problem. If gravity is a force pulling you downward, why don't you feel that pull? Why do you only feel the surface stopping you? Now think about falling. When you jump or drop something, it accelerates toward the ground. That seems like clear evidence of a pull. But during free fall, something surprising happens. You feel weightless, no pressure, no push, no pull, nothing. So which one is real? The feeling of weight or the absence of it while falling? This contradiction hints that our basic understanding of gravity might be incomplete. And then comes an even stranger question. Gravity is supposed to act on mass. That is the rule. More mass, stronger pull. But light has no mass at all. Not even a tiny amount. And yet when light passes near massive objects, its path bends. It changes direction, as if something is influencing it. How can something without mass be affected by gravity? That question breaks the simple picture completely. You might think there is a hidden force acting on light, something we cannot see. But if that were true, we should be able to describe it clearly. Instead, every explanation starts to feel incomplete, like a puzzle missing its most important piece. Something is wrong here. For centuries, the idea seems simple. Gravity is a force. Objects with mass attract each other. The bigger the mass, the stronger the pull. This picture works beautifully. It explains why apples fall, why planets orbit, why the moon circles Earth. It feels complete. According to Isaac Newton, gravity acts instantly across space. The Earth pulls the apple. The sun pulls the planets. Everything attracts everything else. Clean, predictable, powerful. But there is a hidden problem inside this simplicity. Start with something basic. Drop a heavy object and a light one. In a vacuum, they fall at exactly the same rate. The heavier object feels a stronger gravitational pull, but it also resists motion more. Somehow, these two effects cancel perfectly every time. Why should that happen? Why should two completely different properties match so exactly? Then, consider distance. If the sun suddenly moved, the Earth should feel the change instantly according to this model. But how? What carries that information across empty space? What is the mechanism? Even Newton admitted he had no answer. Now bring light into the picture. Light has no mass. According to the force idea, gravity should not affect it at all. No mass means no attraction. Yet observation shows something different. Light bends when it passes near massive objects. It behaves as if gravity is influencing it. This creates a contradiction. The same theory that explains falling objects so well cannot explain why light bends. All right. So we are left with two conflicting truths. Gravity seems to work perfectly, yet it fails. At the same time, it predicts motion with incredible accuracy, but it cannot explain what is really happening underneath. That is the moment where a deeper question appears. What if gravity is not a force at all? When a theory starts failing in small but consistent ways, science does not discard it immediately. Instead, it asks a deeper question. What if the entire framework is wrong, not just the details? This is exactly what Albert Einstein began to rethink. He didn't try to fix gravity as a force. Instead, he questioned whether it was a force at all. To understand this, imagine something simple. You are inside a closed elevator. If it is standing still on Earth, you feel weight pressing you down. Now imagine the same elevator in deep space, far from any planet, but accelerating upward at the same rate. In both cases, you feel identical pressure. There is no experiment inside the elevator that can tell you the difference. Now, this idea is called the equivalence principle, and it leads to a shocking conclusion. What we call gravity might actually be indistinguishable from acceleration. From here, everything changes. Instead of thinking of gravity as a pulling force, imagine space itself being shaped. Massive objects do not pull things inward. They bend the structure around them. They distort the very geometry of space and time, known as general relativity. Now light enters the picture again. Light always travels in straight lines. But what if straight is not what we assume? If space itself is curved, then the straightest possible path is also curved from our perspective. So when light passes near a massive object like a star, it is not being pulled. It is simply following the natural geometry of curved space. This is why light bends. Not because it has mass, but because space itself is bending underneath it. Even more surprising, this means gravity is not something acting between objects. It is something built into the shape of the universe itself. Mass tells space how to curve. Curved space tells everything, including light, how to move. And suddenly, gravity is no longer a force pulling things down. It becomes something far deeper, a structure, a geometry.